Welcome to Weather Extra on CBSN Bay Area. I'm KPIX5 meteorologist Paul Hagen. Every week, we're taking a closer look at a weather topic, a deeper dive than what we can usually do within our daily weathercasts on KPIX. This week, we have an email from a viewer. Greg Hoyman, and I hope I'm pronouncing that correctly, asks, I don't recall hearing the term atmospheric river until recently. It is a very descriptive term, but does it have a meteorologically specific definition or just a lot of rain coming from the same direction? Thanks to Greg for the question, and we're actually going to talk about two phrases you'll hear as we head through the weekend, atmospheric river and also bomb cyclone. These are terms that forecasters use to describe what's happening in the atmosphere, but they're also terms that the national media has recently latched onto because they sound so dramatic, similar to what happens every winter with the polar vortex. In this segment, I want to strip away that hype and just focus on the science of what we're talking about. Meteorologists define a bomb cyclone as a storm system that significantly intensifies within a short period of time. Technically, it's when the central pressure, the low pressure at the heart of the storm system, plummets by 24 millibars, that's a pressure measurement, or more within 24 hours. The process is referred to as bombogenesis, which sounds even more dramatic. As the pressure drops rapidly in the center of the storm, air rushes in to replace the vacuum created in the atmosphere, and that process can produce damaging winds. The bomb cyclone that we're focused on now is the system that's off the coast of the Pacific Northwest on Thursday evening as I'm recording this segment. The area of low pressure will actually rival the intensity of some hurricanes from the Atlantic season this year. Now, this powerful storm is going to bring damaging wind to the coast of British Columbia, but the precipitation it will deliver to Oregon, Washington, and here in California is obviously greatly needed. The storm system is going to drive a band of moderate to heavy rain through the Bay Area late Thursday night into early Friday morning. So keep in mind, this is a recorded segment, so be sure to watch our regular weathercasts on KPIX5 and here on CBSN Bay Area for the latest up-to-date forecast details. While the bomb cyclone is going to trek northward into British Columbia and the panhandle of Alaska, another storm system that's almost as strong is going to impact the Bay Area's weather Sunday and Sunday night. While it's going to follow a similar trajectory, this storm system is going to direct an atmospheric river towards the coast of California. That brings us to our second phrase. Atmospheric rivers are relatively long, narrow regions in the atmosphere that transport most of the water vapor in the atmosphere outside of the tropics. These columns of air move with the weather, carrying an amount of water roughly equivalent to the average flow of water at the mouth of the Mississippi River. The strongest atmospheric rivers can carry 10 times that much moisture, so they really are rivers in the sky. When atmospheric rivers make landfall, they often release this water vapor in the form of rain or snow. Although atmospheric rivers come in many shapes and sizes, those that contain the largest amounts of water vapor and the strongest winds can create extreme rainfall and floods. But not all atmospheric rivers cause damage. Most are weak systems that provide beneficial rain or snow that's crucial to our water supply. Atmospheric rivers are a key feature in the global water cycle and are closely tied to both water supply and flood risks, especially here in California. A well-known example is the Pineapple Express, an atmospheric river that brings moisture from the tropics near Hawaii over to the west coast of the U.S. A weak version of the Pineapple Express is responsible for our early Friday rain, but it is a stronger atmospheric river as we wind the clock forward that will impact us on Sunday. Like with tornadoes and hurricanes, meteorologists do use a numeric scale to rank the impact and strength of atmospheric rivers. This is data from the Center for Western Weather and Water Extremes, a division of the Scripps Institute of Oceanography at UC San Diego. It's a lot of information here, but I want to take you through it. Here on the left, the colored dots along the coast correspond to the strength of the atmospheric river to impact any point along the coast. In the case of Sundays, it's an AR3 out of that scale of 5 for the Bay Area, which is significant, especially in the month of October. In the middle, this is a time series that uses forecast model data, in this case, the ensemble of the European forecast model, to track the intensity and duration of atmospheric rivers in the forecast. So this yellow area indicates the weak atmospheric river Friday, and the second yellow area is a stronger, it's almost tipping into orange, highlights Sunday's higher impact event. Finally, on the right is a chart that lets forecasters quickly assess the magnitude of the forecasted atmospheric river. We measured that magnitude with two metrics, the sheer amount of water vapor being transported by the storm system and the duration of the event. In this case, because we're looking at a longer-lived system with moderate to high vapor water transport, that's the B on the chart there, the atmospheric river is forecast to be strong, but not extreme or exceptional. This is the most accurate forecast model in the world, so that gives us some confidence in its output. But that said, there are other models showing the possibility of an extreme or even exceptional AR5 event Sunday and Sunday night. Those higher categories are the ones associated with flooding, mudslide risk, debris flows. That's something we'll be monitoring carefully into early next week. Two things to note. First, like all forecasts, this relies on computer model data. If the model data is garbage, our assessment of the atmospheric river is going to suffer accordingly. Second, and I'm emphasizing this yet again, I am recording this segment on Thursday. We're going to be looking at updated versions of this. We get new runs of this every 6 to 12 hours, and all the other forecast models to keep you up to date on KPIX5 on how much rain we expect, when it will move in, and when it will move out, and any consequences, impacts it's going to have. I just wanted to give you a little behind-the-curtain peek into part of the forecast process. That's it for this week's Weather Extra. Meteorologist Darren Peck will be back next week to cover another topic, and we are inviting you to play a role. If you have a weather or climate question, just email it to weatherextra@kpix.cbs.com.